All right, today we're going to learn about parabolas. These are parabolas in vertex form, and this is the form that you're going to want to use when you do your Desmos project. Vertex form looks like y equals a parenthesis x minus h, close parenthesis squared, plus k, where hk is the vertex. You'll see there's two different forms of the vertex form of a parabola. One of them is a parabola that opens up or down, like the one that I just wrote. However, we're also going to have parabolas that open left or right. The other thing that's different is instead of just one value right here, we do have one value. It's just broke apart into 1 divided by 4p. And this p value is going to give us some information in just a moment. Remember, if the number in front of the parentheses is negative, then it's a reflection. So normally these open up, parabolas open up, but if this number out front is negative, it's going to open down. And then these parabolas right here open left and right. Normally positives go to the right. So if this is a negative, it's going to reflect and it'll open to the left. The vertex, no matter which one we use, is HK. Just have to be careful here because the H is out and the K is inside the parenthesis here. Now we're going to have a focus for our parabola. So once you have a parabola, you're going to have a focus, which is a point on the inside of the parabola. And to find the focus, you go from the vertex and you go p units away. So that's why we have this broke apart, so you can find the actual p value. And then there's something called a directrix, which is a line, and it is outside the parabola. It is a line, so we have to write it as an equation. In this particular picture, the equation would be y equals some number, and it is also p units away from the vertex. Now if I have a parabola that opens to the left or right, then the focus would still be on the inside of the parabola, and the directrix would be x equals some number. So our first example, x squared equals 8y. This is not in vertex form. To be in vertex form, the variable that is to the first power, we need to solve for that variable. So I'm going to have y equals, I'm going to divide both sides by 8, but instead of writing it divided by 8, I'm going to change it so it's 1/8 x squared. So we're going to, instead of dividing by 8, multiply by the reciprocal. We look up here and, excuse me, this one is an up-down parabola. This is a positive number right here. So this is going to be opening up. Our vertex, there's no numbers inside being square. There's no k value out here, so it's just 0, 0. Go ahead and graph that. We know that it opens up. Our p value, you are going to take your number in front and we're going to excuse me, set that equal to 1/4p. You could cross multiply to solve that. In this case, since 1's are the same, then 8 has to equal 4p. So I'm using some common sense here. Divide, and we get p equals 2. So p equals 2 is our p value. So to find the focal point, we need to go 2 units from the vertex. And we're going to go 2 units in the direction that it is opening. So I'm going to use that it opens, and we're going to add 2 in that direction. So on the graph, I just go up 2. If I were using the ordered pair, since I'm going up, I would add 2 to the y value. So our focal point is at 0, 2. And then the directrix goes the other direction. So since I went plus 2, I'm going to subtract 2 for the vertex, or for the directrix. So I'm going to go down 2. But that is a line. That line is going to be y equals if this original equation was a y equals. So that kind of gives you an idea of which variable the directrix will use. It's going to be the exact same variable that is to the first power here. So this is going to be y equals -2. Now to graph parabolas, I want to see 5 points minimum. Enough points to graph an accurate parabola. So I have a little trick that if you know the p-value, that you can find 2 points super easy. It has something to do with a latus rectum, but I'm not good. That's something that I cut off from previous years, so we don't really need to know anything about it. But if you'd like to use this trick to help you graph it quicker, you take 2 times the p-value, and then we're going to add and subtract to the focus value, to the focal point. I'm going to add and subtract that to the focal point to find width. So it's going to go in the opposite way that the focus and directrix went. Or I should say opposite direction that the parabola opens. Opposite direction, the parabola opens. So if I do 2 times my p-value, I'm going to do 2 times 2, which is 4. And I go to my focus, which, you know, it'd be nice if I labeled it so then I could not get confused between the points. I go to my focus and I go out 4 in both directions. And those should be points that are on the parabola connecting through the vertex. That only gives me 3 points, so I guess I'm stuck either making a table of values and doing transformations like we've done in the past, or maybe just plugging in one value because I really just need one other point and a mirror. So if I'm plugging in a value for x, I'm going to plug in something that I can multiply by 1/8 easily and don't have to deal with fractions. Maybe I'll plug in, let's see, I can't plug in 4 because that one's already 4. So maybe I'll plug in 8. If I plug in 8, then I'm going to get 1/8 of 64, which is 8. So the ordered pair 8, 8 should be a point on the graph. Now, you're sitting at home and you have technology. You're more than welcome to use your graphing calculator or your Desmos calculator to check to make sure that you're graphing these right. On a quiz or a test, it's very possible I will ask you questions that you will need to know how to do this without a calculator, but while you're at home, definitely check your answers. The biggest problem that we have when we're at home is you can't ask those questions immediately to me unless you come in my office hours. So use the technology that you have available to you. Here's a few more examples. Example 2, y squared equals 16x. So this is y squared. I need to solve this for x. I'm going to divide both sides by 16 or just multiply by 1/16. And I get x equals 1/16 y squared. So this is the kind that opens left or right. Because 1/16 is positive, this is going to open to the right. The vertex is at 0, 0. Our p-value, I'm going to use that formula from the front, 1 over 4a equals 1 over 16. And since the 1's are equal, then the 4a has to equal 16. And divide by 4, and I get a equals 4. I'm sorry, P. I don't know why I have an A in there. So P equals 4. My p-value is 4. The focal point is going to be 4 units in the same direction that the parabola opens, 4 units to the right. So since I'm going to the right, I'm going to be adding that 4 to the vertex x value. And then the focal point is at 4, 0. The directrix is going to go -4 from the vertex. So we're going to go 1, 2, 3, 4. And since this is x equals here, this is also going to be x equals. It's going to be a vertical line at x equals -4. Now, I need to find at least 5 points to graph this. I have 1. So I'm going to use that trick that I taught you in the first one. You do 2p, which is 2 times 4, and we go from the focal point and we go in the opposite direction that I went for the parabola opening. So instead of going right or left, I'm going to go up and down 8. All right, and then I need to find one other point. So maybe I'll just plug in a number that would be easy to multiply by 1/16. How about I plug in y is 4. Let's do it down here. X equals 1/16 if y is 4. Then I get x is 1. Just be very careful when you plug stuff in because this is backwards. 1, 4 is the ordered pair that I'm going to graph. 1, 4. It also would work if I, oh no, yeah, so 1, 4. If I had plugged in -4, I would get the exact same answer. So 1, -4 is another point. And remember, we have this thing called the axis of symmetry, which is right in the middle of the graph, which is a mirror point. So if I just find this point, I know there's one on the other side too. Okay, and then there is our parabola. All right, question C is not in vertex form, so we have to look carefully. I notice that y is to the first power and there's no other y's. X here is to the first power, but x is also the second power. So this is the kind where I'm going to solve for y. So with the x's, we need to complete the square. We have x squared minus 6x plus a square equals 4y minus 29 plus a square. We're going to complete the square by doing -6 over 2 squared, which is -3 squared, which is 9. And I'm going to factor it. X minus 3 squared equals 4y minus, let's add this together, 20. All right, we're trying to solve this for y. So I'm now going to move the 20 over. I'm just going to rearrange it slightly. 4y equals x minus 3 squared, and I move the 20 over, add 20. Okay, we have to either divide by 4 or multiply by 1/4, but you got to be careful because we got to do the entire side. So when I divide the entire side by 4 or multiply the entire side by 1/4, I'm going to get y equals 1/4 x minus 3 squared plus 5. So if I don't divide that, we're definitely going to have the wrong vertex. So my vertex is 3, 5. This is a y equals, the number up front, 1/4 is positive, so this is going to open up. The p-value, I need to take 1/4 and set that equal to 1/4p. And then I set my denominators equal to each other. P has got to be 1. So my focal point is going to go up 1. Again, we're going in the direction that the parabola opens, up 1. So that's my focal point. I can either go over here to the graph and figure out what point that is, or I could just say, well, I added 1 to the y's, so 3, 6. The directrix is going to go in the opposite direction. So my directrix, I'm going to subtract 1, and I'm going to use y equals, because that's what the equation for this parabola is, y equals, it's going to be 1 lower, and that's going to be at y equals 4. Graph it easy, I'm going to use this 2 times p trick that goes out from the focal point. So 2 times our p-value is 1. I'm going to go 2 units from the focus, from the focal point. So from the focal point, I go out 2 units in either direction, and I have 3 points for my graph. Now, I can just plug something else in, but I want to review how to find the y-intercept. Because if I find the y-intercept, I'm going to find another point, and then I can just mirror that for the 5th point. So the y-intercept we find by plugging in 0 for x. And it doesn't matter which, if you use this equation or if you use the original. I'm just going to use the original, but it doesn't matter which one you plug in 0 for x. Plug in 0 for x, we'll get 0 squared minus 6 times 0 equals 4y minus 29. So I'm going to solve that for y. 29 equals 4y divided by 4. And it looks like y is 7 1/4. So my y-intercept is at 0, 7 1/4. That seems like it would make sense. And then I go on the other side of my axis of symmetry, and I go over 1 and I go up 7 1/4. So this is what the parabola should look like. Oh, I went too far on that side. All right, last graph. This would be a really good time for you to pause it and see what you're understanding and see what you're not understanding. I'm just going to keep talking, but if you have it paused, then you can unpause it to find out if you did it right. So I'm going to look at this one here, and I notice that x is the variable that is not squared. So x is what I have to solve for. Let's see. I'm going to move the 10x and the 9 over. And I'm going to complete the square with y. Y squared plus 2y plus square equals negative 10x plus 9 plus square. Complete the square and I get 1. Factor it, we get y plus 1 squared equals, combine over here, I get negative 10x plus 10. Now we're going to solve for x, so I have to subtract the 10 from both sides. And then after that, I'm going to divide everything by negative 10. Negative 10x equals y plus 1 squared minus 10. Divide everything by negative 10. I'm just going to write it over here in purple so it stands out. X equals negative 1/10, parenthesis, y plus 1 squared plus 1. So our vertex, here's where we got to be careful. Our vertex, when it's in this form, the thing with the y is the y part of the vertex. So this has to be opposite, has to be negative 1. And then the number on the outside is the x. So that's going to be positive 1. So if we're not careful, we don't take our time, it's possible we get this backwards. Negative 1 is the vertex. And if you're using Desmos to check, then you would find out right away, oh shoot, I went backwards. Which way does this open? Because it's x equals, it's going to open right or left. Because it's x, and x goes right or left. The negative here tells me it's going to open to the left. The p-value we find the exact same way. We're going to take negative 1/10 and we're going to set it equal to 1 over 4p. So the p-value here, maybe I cross multiply. Sure. Negative 4p equals 10. Divide both sides by negative 4. And I get p equals negative, and then I reduce it 5/2. So we are going to go to the left 5/2. Okay, the negative right there is telling me it's going to the left. I'm not doing left negative. I'm doing left 5/2. So from here I'm going to go 1, 2 1/2. Or you could go to the x value up here and subtract 5/2. That is at negative 1 1/2 or negative 3/2, comma, still y is negative 1. So there's our focal point. The directrix is going to go in the other direction. We're going to go 5/2 or 1, 2 1/2, 1, 2, this direction. And this is an x equals kind, so we're going to go up and down, x equals for our directrix. X equals, what is this, 3 1/2, 7/2. See, to graph this, I need to find some points. I'm going to use this trick that says 2 times the p-value is going to be how far it is from the focus. So 2 times negative 5/2 is going to give me negative 5. And I wouldn't worry about negative or positive. You're just going to go 5 up and 5 down from the focus. Now I only have 3 points. I'm going to take this moment to review how to find x-intercepts. I said intercepts because I know that it's going to hit the x-axis. Oh shoot, that's not x-intercepts, y-intercept. My bad. It's going to hit the y-intercept twice because it opens to the side. To find the y-intercept, we are going to plug in 0 for x. And I'm going to do that with the vertex form. Now, you can do it with the original, and you can solve it a different way than I'm about to solve it. But I'm going to do it with this vertex form question. I'm going to make x equals 0, and then I'm going to solve for y. So I'm going to put 0 in for x. And we're going to solve for y. So subtract 1. Negative 1 equals negative 1/10, y plus 1 squared. Multiply both sides by negative 10. I get 10 equals y plus 1 squared. So now I have to square root. Remember, when you square root, you plus minus. That's how we're going to get 2 answers. So I'm going to have y plus 1 equals plus minus square root 10, and then I'm going to subtract 1 from both sides. Negative 1 plus minus square root 10. Now, to graph it, I would need to type that into my calculator, which I already did. So I typed that into my calculator, and one of the answers is approximately 2.16, and the other one is negative 4.16. And those, again, are y-intercepts. I'm going to go to the y-axis. I'm going to graph at 2.16 and negative 4.16. We connect those. I have a nice, accurate-looking parabola. Right, the last part of these notes would be starting with information and writing the equation. So here, here I've got the focus and the directrix, and we have to find the equation. To find the equation, we need the vertex. So I didn't give you graph paper. You're more than welcome to print out as much graph paper as you want, or use the graph paper that I sent you on Cami. Write the equation of the graph parabola if the focus is at negative 4, 2. So negative 4, 2 is about there. And then directrix is x equals negative 6. So the x equals negative 6 would be 2 further, and it would be up and down. So the vertex has to be exactly in between those. So I can tell right now the vertex is exactly in between 4 and -6. So the vertex is going to be at -5, 2. I also know that the directrix is x equals, so my equation is going to be x equals when I'm done. And by the picture, I should be able to tell that it opens to the right. So that tells me the p-value is going to be positive. So what is the p-value though? The p-value is the difference between the vertex and the focus. So p is 1. So we're going to write this equation, x equals 1 over 4 times 1, parenthesis. We do y minus k, so y minus 2 squared, plus h, which is -5. So x equals 1/4, y minus 2 squared minus 5. Question B, write the equation of the parabola if the focus is at 6, 2 and the directrix is at y equals 3. So this is a lot like this question. We've got 6, 2, 1, 2, 3, 4, 5, 6, 2. Then we've got our focus, and our directrix is at y equals 3. So our vertex has to be right exactly in between those two. So in between 2 and 3 is 2.5. Or 5/2. So let's see. The vertex is at 6 and then 2.5 or 5/2. We need our p-value. The p-value is the difference between the focus and the vertex. So 1/2, except if we look carefully, it's going down, so this is going to be -1/2. And y equals over here tells us this equation is a y equals equation. So we go 1 over 4 times our p-value, and then we do x minus the h squared plus 5/2 our k, and then we're just going to simplify this right here. Y equals 4 times -1/2 is -2. So -1/2 x minus 6 squared plus 5/2. Last question, write the equation of a parabola if the vertex is 3, 4 and the focus is at 3, 7. So the vertex is 3, 4, the focus is at 3, 7. So the focus is telling us that this parabola is opening up. So this parabola has to be a y equals. The difference between 3, 4 and 3, 7 is our p-value. So p is 3. So we're going to do 1 over 4 times 3. X minus, our vertex is 3 squared plus 4. So y equals 1/12. Ooh, that was ugly. 1/12. X minus 3 squared plus 4.